Hi everyone, my name is Zuhaib. I hope you guys are doing well. Today we are going to discuss on a very good, interesting topic. That is how we can save up our cost on OpenAI API LLM calls. And yeah, so there are two very simple methods and techniques through which you can save your cost and speed up your LLM response time as well. So without any waste of time, let's start it. So there are two methods, as I said earlier. One is caching and the other one is batching. So you already have heard the name of caching that you use generally on your CPU machines in the form of random access memory. So you can also configure a cache when you make your OpenAI LLM calls with the help of LangChain. So LangChain provides us the facility to configure a cache. So how the cache can will be used, so whenever you make a call to an API in the form of some kind of prompt and you receive some kind of a response in the form of a completion, so when you configure some kind of a cache, your response and your prompt is saved inside somewhere, and whenever you make a similar query again, then the response you will get from your cache instead of calling your LLM again and again. So this process saves you a lot of cost in your applications, like in chatbots or in other um content creation applications. So yeah, so we will see that how we can implement the cache inside our code. So yeah, let's start it. So to implement the cache, we have to install some libraries, which includes the LangChain, OpenAI, SQL, Alchemy. It provides us very good tools to connect to different kind of databases through Python. So yeah, so SQL Alchemy is very helpful for that, and other than that we will use python.env, which will is helpful to load the environment variables in which our secrets or critical information is saved. PyMySQL, so this library will also be used because we will be using a MySQL database for caching our responses. So let's install them. So it will take a while to install these all libraries. So, by definition, caching in large language models is a technique for storing the responses to common prompts and queries so that they can be retrieved quickly and easily without having to call the LLM again and again. So whenever you make a call to your LLM, the OpenAI charges you, and it depends upon how much tokens you send as input and how much tokens the LLM generates and sends you back. So OpenAI charges you on the basis of number of tokens. So by implementing the cache, you can save the responses of general queries that comes again and again from the user side, which will help you to save a lot of cost and will also speed up the response time as well. So there are two types of caching that are used in LLM. One is exact match cache. So it matches the query from the user side with all the queries placed in our database. Yeah, so it matches your user input with all that responses, and whenever it gets a match, then the corresponding response is returned to you. So yeah, so the other type is like embedding similarity cache. So in this type of cache, the embeddings are calculated of your user input query, and then it is being matched with all the inputs that being already stored. So the similarity score is being calculated, and the input which is with the highest similarity score, the respective response is returned accordingly. So these two types of caches can be used by using the LangChain. There are pros and cons of using these caches. So, but in this tutorial, we will be configuring the exact match cache because that is more useful in our case. So, if we make the comparison of these two caches, cache hit rate is lower when you use exact match cache because Generally, it happens that there are very few times the user input matches with already stored inputs. So that's why the cache hit rate in that case is lower. And in the case of embedding similarity cache, the cache hit rate is higher because it depends upon the similarity score. And whenever you get a high similarity match, then you get the response from the cache. The complexity of exact match cache is simpler because you just have to match your input against already stored inputs. And but in the terms of similarity cache, the complexity is very much higher, and it needs more computational resources because in the terms of embedding calculation, the embedding does not always match exactly with the already stored embeddings inputs. And you may get the false responses being saved from your cache. So you have to make a very optimized solution whenever you use the embedding similarity caching. So we are going to discuss two types of caching in this tutorial. One is in-memory cache, and the other is SQL Alchemy cache. So this cache is implemented in your own machine memory. So we are going to import these couple of libraries: OpenAI LangChain OS in a memory cache module from the LangChain, and OpenAI LLMs as well, and a load.env library. So yeah, so let's run them, and we will be importing some environment variables like the OpenAI API key as well. So here we are setting the in-memory cache uh, by calling this command like langchain.llm cache equal to in-memory cache function. So it will initialize our in-memory cache. So whenever we will make a call by using the LLM, it will save our input and the corresponding response inside the cache that is stored in our own CPU machine. So here we are setting up the LLM text DaVinci 002, and we have set the cache to true, and max tokens will be used 50. So we have set the cache to true because we want to use the cache. If we do not want to use the cache, we can set it as a false because sometimes we do not want to store cache for some intents, and therefore we can use the cache equal to false for such scenario. So let's ask the LLM to make a joke. Tell me a joke. So you have to note down how much time it takes to get the response. Yeah. So it took, I think, 1 to 2 seconds to give us the response, and it says two guys stole a calendar. They got 6 months each. Okay, so it was funny. And yeah, whenever you make a call to LLM, every time the output response changes. But in whenever you implement the cache and you make every time the same query to the LLM, your response will also be the same. So now if we make this call again, you will see that we will get the same response, but this time the response time will be very shorter as compared to when you make made your first call. So let's run it as well. So you can see that it we got the same response because the cache has been implemented on the back end, and we are getting the response from the cache instead of the LLM. So we are saving the cost against the queries that are being asked from the user side again and again. So in general scenario, we use some kind of a database to set up our cache, and we store all our queries and their corresponding response inside some kind of a database so that later you can visualize the responses like your application is working right or wrong in terms of quality. So now we are going to see that how we can implement SQL Alchemy cache using LangChain. So we are going to import SQL Alchemy cache from LangChain. Yes, create engine as well. And also we are going to import the declarative base. So this is the default base class that is being defined in SQL chain. So the next one is from SQL Alchemy, we are importing the column, integer, and text. So these are some kind of a defined classes that will be used to create the tables inside our database. Yeah, so the code plus is generally used to quote the password in the form of a UTF-8. The next one is OpenAI LLM, and yeah. So here I have declared the declarative base that will be used inside this full text LLM cache class. So this code has been given on the LangChain website, so you can refer to it later for more clarity. But yeah, so this base class is will be used here as a parent class, and here we are setting the table name. So later when you will run this code, table with the name of LLM cache full text will be created inside your database. So this table will be used as a cache for your LLM calls. So here we are defining the different columns inside our table. This table name, this one column is of integer type, and it is also being set as primary key equal to true. So the name is ID of that column. The second column is with the name of prompt, and it is of text type. Similarly, there is a column with the name of LLM, and it is also of text type. The other one is IDX, which is of integer type, and the response will be saved with the column name like response, and it is of text type. So it is just the configuration of your table that will be used as a cache inside your database. So whenever you make some kind of a SQL or MySQL database, then you are being written with some kind of a credentials against your database. So we are importing those credentials like the username, password of the engine on which your MySQL database is hosted, endpoint URL, database name, and also the API key that we imported already. So let's import these environment variables. Yeah. So here we are going to configure our cache, and then later we will use that cache as well. So yeah. So this is the form of a connection that we will make with our MySQL database, and PyMySQL has been used. So this is F string. Here the username that has been given to you when you created your database engine. So the password will also be given to you, endpoint URL and database. So in the this format is being used for the S string, and it has been set it as DB URI. So this string will be used and to configure and create engine for your LLM cache. So here we are giving this URI, and yeah. So these are just the configurations that will be used. So cache engine has been set up, and which will be used inside our SQL Alchemy cache class from the LangChain. So we are giving the cache engine here, and also the already configured full text LLM cache class here. So this all has been assigned to LangChain.llm cache that we also did earlier when we configured the in-memory cache like here. So yeah, so the next thing is we are defining the LLM from OpenAI text dimension 003 for it, and I have set the cache to true. So let's see what will be done when we run these commands. So LLM cache has been created inside our database. We will see how it looks, but let's ask some questions by using this LLM. So let's ask like, who is the prime Minister of India. So it says like the Prime Minister of India is Narendra Modi. So now we ask like who is the Prime Minister of Pakistan? So it says like Prime Minister of Pakistan is Imran Khan, but it is he is no more. Anyhow, now we have asked the two questions from our LLM. So let's see where these queries and the responses has been saved in our database. So let's go to our SQL MySQL database and see where things have been stored. So here you can see a table name with the name of LLM cache full text, and we have saved the corresponding queries that we asked from the LLM here, like who is the Prime Minister of India, who is the Prime Minister of Pakistan. So we these are the columns that we already talked about: ID, prompt, LLM, IDX, and response. So these columns will save your different kind of informations about the LLMs. Like the LLM column will save the information about the LLM, like we are using the text dimension 003. Also the response column like saves the response of your query. So yeah, so now if we see like now if we ask the same question again, then we will get the same response without any change. Like I am asking again, who is the Prime Minister of India? So the response time, you saw that the response was very quick, and the response is also the same. The Prime Minister of India is Narendra Modi. So it has not called the LLM again. It went into the cache and matched the user input, like who is the Prime Minister of India. So it matched with your already stored queries, and you got your response from the LLM cache instead of calling the LLM. So you save your LLM API call cost. So this was the first method that can be used for saving cost on OpenAI LLM calls. So the second method is like batching. So batching is just like you bundle up many different requests to LLMs, and then you just send all the calls in one turn. And this is called batching. So if we see the definition of it, it says like so it says like if you are sending multiple requests to the same endpoint, you can batch the prompts to be sent in the same request. So this will reduce the number of requests you need to make. The prompt parameter can hold up to 20 unique prompts. So you can send 20 unique prompts in your one call. So sometimes you face the problem of rate limits by OpenAI. So in that situation, you can use the batching. So what are rate limits? Like a rate limit, it's a kind of restriction that an API imposes on the number of times a user or client can access the server within a specified period of time. So you cannot access the server all the times in a specified period of time. So there are some kind of a rate limits imposed by the OpenAI. So if you are facing this problem, then you can batch your requests to save the cost, and also you can speed up your response as well. So so here is an example being implemented in which we do not have used the batching. We are creating some number of stories like five, and with the same prompt like once upon a time. So so it will try to complete this prompt by generating some kind of a tokens. Here we are using the for loop, and we are calling this endpoint that's with this model again and again. So we are making a total five requests to generate five stories. So so without batching, you have to make your API call again and again. And but if you see the batching code, like here, you are just sending the five same prompts in your one call. So This will optimize and the speed, and also will optimize the cost of your OpenAI usage. So you are making just one request, and with the five number of prompts, and you are getting the five stories against them. But in this use case, you have to write the code to get the corresponding stories for against your prompts. So this was the way you can use the batching for optimizing your cost. But generally, you think that where you can use batching in general applications in our daily life, you cannot use them in your chatbots, because in chatbots, you get the input from the user side, and you cannot concatenate them time by time, so that you can use batching to get the response against all your user inputs. You just have to send the response immediately against your user input. But whenever you create some kind of a marketing content, and the content for the teaching purposes like essays, you can bundle a number of calls to your open API inside your one request, and can speed up your process of getting a response. So this was the batching. And one thing I missed earlier, like by using the LangChain, you can implement a number of different type of caches depending upon your use case. Like you can implement SQLite cache, Redis cache, uh, GPT cache. Though, so these are different types of caches you can implement as per your application need. So guys, that was all for today. If you guys have any questions, then you can comment below. And if you guys still have not subscribed my channel, then subscribe it as well. And till next video, see you guys. Bye bye. Take care.